Can you see my slides? Can, right? Okay. There was a glitch just now. Wheeler, can I ask, how did you put the parrot there? Is it a parrot or just a bird? So cute, you know. I saw a few students did that. I was wondering, how did you all do this? Interesting. Yeah. Then one by one, all of you will start putting something beside your face. You can share with me, right? Later you tell me, I want to learn. It's a parrot. Chat filter. I see. Okay. Wonderful. That's fun. Can. So let's look at this question now. RAM set up a doorbell D using 2 circuits containing 2 switches as shown. Yeah, so the switches, as you can see, if you can't, let me highlight to you first. Okay, you have a switch here. Okay, and then there's one more switch. So you have 2 circuits, right? Circuit A, circuit B, and then there are switches in each of them. So you have to explain, how come the answer was here? But never mind. You have to explain how the doorbell rang when RAM closed circuit A. So if you were to look at the answers, it doesn't matter. Okay, you have the electric current being able to flow through the iron bar. So where is the iron bar? This is where the iron bar is. Okay. Iron bar means this part here. Okay. So you have the iron bar, electric current flows through it, right? Then it magnetizes this iron bar into an electromagnet. Yep. So when it's an electromagnet, it is going to attract the magnetic material. And over here, okay, it is attracting the iron arm. So this iron arm here, all right. What happened is there is the attraction. Let me show you the attraction. Where is it? The attraction is here. Okay. So the iron arm is being attracted. It's pulled downwards. As it moves downwards, okay, it's going to also move downwards towards the circuit B. As it does so, the iron arm will push the switch. Can you see that? And it's going to close the switch. Yeah. So after closing the switch, that means after closing, current can flow. When current flows, the doorbell actually rings. Can you see that? So I have answered part by part for you. Look at this. I think I changed a little bit of the answer. So you might want to take a look at this one. Okay. Electric current was able to flow through the iron bar. All right. Magnetizing it into electromagnet. Okay. And then, second part I have answered for you also. Attract the iron arm and then close the switch in circuit B, allow electric current to flow, thus ringing it. Right, this may be a 3-mark question. Okay, and how will this be allocated? First mark. Okay, will be here. Talk about this iron bar being magnetized into electromagnet because the current flows. Then next thing you will say is, okay, electromagnet attracted the iron arm and caused the iron arm to close the switch. Okay, I put 1 mark here better. In circuit B. And the last point, electric current flow through the whole circuit, passes through the doorbell, therefore ringing it. This will be the 3 marks. Clear? Okay, so how many marks do you have? Usually, you will write very short answers. You realize that? Okay, if you write 2 short answers, you cannot get the marks there. Okay, Josiah, in case you're wondering, this is actually last week's question. We didn't manage to finish. Okay? Yeah. Can I go on? So now, Okay, Ram replaced spring R with another spring. So now I indicated this is spring S. And he observed that the doorbell did not ring when circuit A was closed. Can you give a reason why? How come the doorbell doesn't ring? So after closing this switch here, right? Okay, after closing, it seems like the doorbell didn't ring. So what does it tell you? Want to guess? What's the first thing you will think of? It's okay to try. Don't worry, you just try. Okay? Somebody just got to share a possible answer and then let's discuss. Let's see. Maybe I can get Vinoli to try. Jason, you can try also. Just type into the chat. Okay. This is spring S now. Circuit B is not closed. So Irene said, when the doorbell didn't ring, that means circuit B is not closed. Okay, if circuit B is not closed, how come? Okay, circuit A closed, but circuit B not closed, right?
I think there's something to do with circuit A, and then when something is, when circuit A is like closed, and then like something activates the iron arm that pushes the switch for circuit B.
Yeah, but it didn't happen, right? In this case, that's why, right? So what could that be? Okay, I have many answers coming in. Good. Yeah. Let's see. So yeah, Irene said circuit B is not closed. That is part of the answer, you know. That's part of the answer. Circuit B is not closed means it's an open circuit. But why? Then let's say, is it because it is not a conductor electricity? What is the it you are talking about? What is the it? Then Siran said, is it because spring S and spring R materials are different? Yeah, so Siran has this question. Yeah, and she thinks it might be the possible answer. Okay, so let's say is spring S is not conductor of electricity. What about you, Kenneth? What do you think? Okay, Jason already said something, right? Okay, Irene also. Xiang Kun, did you say something? Xiang Kun, let me see. Xiang Kun say spring S is not flexible. Very close to what Siran mentioned, right? The material, right? Something to do with the material. Okay, so Siran mentioned something about the material, and then Xiang Kun said spring S not flexible. Are we getting closer? Yeah, we're getting closer to the answer, right? Vinuli said spring R is conductor, spring S is insulator. Similar to what Wheeler said. But does it matter? If you're talking about spring R or spring S, is this part of the circuit, right? Is this part of the circuit, right? Does it matter? Will the spring lead to open circuit or closed circuit? Is it part of the circuit or is it outside the circuit? Is it part of or is it outside? Jiaqi, are you here, Jiaqi? Yeah. So what do you think, Jiaqi? Okay. So I'm going to give some comments now. All right. I'm going to give some comments now. Think about Xiang Kun's answer. Xiang Kun said, spring S is not flexible. So what do you understand by flexibility? Jessian?
That means that it can be like stretched for like
let's see. I don't have a plastic ruler. Okay. I have a metal ruler. All right. See, if it's flexible means what? I can actually bend it, right?
you can actually bend it and like,
Yeah. But do you think I can bend my metal ruler?
no, unless you want to break
Yeah,
it.
the law. No, I won't break it lah, but it will just end up being bent and doesn't want to go back to flat again, right? Yeah. So I cannot bend it easily. Okay, the word is easily. Good. So would you say or would you use the word flexible for spring? What is the word that we use for spring? Someone tell me. See whether you all know. Huh? Expand. Is it expand? Stretchy, something like that, whether it can stretch, okay? So if you look at the spring, let's say from your pen, yeah? So you can either press it down, that's compressed, okay? Or you can actually pull, it will stretch or extend. Have you all come across this? Yes, you can go, Josiah. Now, so you talk about the spring, whether it can be, in this case, do we compress it? No, right? It's about stretching, correct? It's about stretching, it's about the extension. So what can you say about this? Actually, some of you already got the right idea. C1 also got it, but it's the writing down that is difficult. So look at this answer, okay? Something to do with the material, right? So we say that spring S was more stiff. What's the meaning of stiff? That means it cannot be pulled, right? Jason, cannot be pulled, cannot be extended easily. So the extension was not enough. That means it's a very hard spring. Usually somebody will tell you, oh, this spring is so stiff, so hard, right? Cannot compress it easily, cannot extend it easily. So when that happens, the extension over here, okay, will not be enough for the iron arm over here. See, the iron arm is here. So it's not going to come down as much as we wanted.
And
so when it doesn't
like
move,
close circuit.
yeah, when it doesn't come down enough, it cannot close the circuit, right? So I have a few of you giving me different parts of the answer, correct? So cannot close the circuit, so circuit was open. Okay, then somebody talked about the spring material, right? And then somebody said it's not so flexible. Okay, better word is actually this one, more stiff. And then extension was not enough. Now, honestly, you wouldn't know extension unless you've done the experiment for spring. Have you all done that when you explore materials? No. Okay. You will also be doing this kind of experiment when you are doing the topic on forces. Not yet, right? You're in P5 now, so you have not done this topic yet. When you are doing this topic, you will be doing extension of the spring. Okay, and the spring cannot be extended all the time, right? It will only go up to a certain limit and then it is deformed. So that means the elastic limit is reached. Okay, it cannot go further. Okay, so this is what happens. And this is actually adapted from a PSLE question. Yeah, you see this whole question, right? Yeah, it is very much PSLE style. So if you want to be better prepared for PSLE, Okay, I will tell you these questions